Hey students, it's me, Mr. Fitz. So today we're going to talk about special triangles, notably the right isosceles triangle, which we see dancing right here. I don't know, I found this by somebody by named of Ashley James. I don't know if they created it or not, but that was pretty cool. Anyway, so that's one of the special triangles we're going to look at is the right isosceles triangle, also known as a 45-45-90 triangle. And we're going to also look at the 30-60-90 triangle today. So let's take a look. Okay, students, so I'm just going to take us through some trig ratios that we should just definitely know, and I'll try and teach you some ways to remember them. So here are two of our special triangles right here. We have the 30-60-90 triangle and the right isosceles triangle, which is the 45-45-90 triangle. So we're going to just like fill out this table. You can, if you want, you can download the video notes online, and you can take notes along, or if you just want to write down your notebook, that's fine. So if you want to pause the video and create this table, I recommend it. So here we go. First of all, we're going to look at starting with the reference angle, and this theta actually just means that's the reference angle. It's just a Greek letter. Think of it as just another variable. We'll talk about the reference angle of 0 a little bit later in the year. When we get to the unit circle today, we're just going to fill in the table. The sine of 0 is 0. The cosine of 0 is 1. And the tangent of 0 is 0. Now 30 degrees, so let's say our reference angle is this angle here, and then don't forget our good friend SOHCAHTOA. So the sine of 30 degrees is the length of the opposite side over the length of the hypotenuse. And you can see that it's actually 1/2, right? If we think if this would be 1 up to here, well, it's just 1, 2, 3, 4, 5 boxes, so it's so that's 0.5. Each of these boxes represents 0.1. So that's the scale of this graph here. So yeah, that's 1/2. So, and you can see like the length of this side over the length of the hypotenuse, yes, it's 1/2 of the hypotenuse. So that's the sine of 30. Now the cosine of 30, remember, is the adjacent side over the length of the hypotenuse, and that is radical 3 over 2. If you plug that into your calculators, you're going to get about 0.87 or something like that. And if you look, 1, 2, 3, 4, 5, 6, 7, 8, yeah, almost 9. So yeah, that's a 0.87 is radical 3 over 2. And then the tangent of 30 degrees is either 1 over radical 3, but that's not a rational denominator. I don't care too much about rationalizing denominators, but Delta Math does a little bit. So we would write that as radical 3 over 3. They're equivalent. So yeah, and actually what you'll notice here, and we'll get to this when we get to the unit circle later on in the year, is if this is our reference angle, look, the sine is actually this y distance, and the cosine is this x distance. Interesting. So that's just wanted to throw that out there. Let's look at 45 degrees now. So here's our reference angle down here. And so the sine of 45 degrees is radical 2 over 2. So radical 2, the opposite side over the hypotenuse. So the length of this is actually about 0.7, which is what radical 2 over 2 is if you plug that into your calculator. And actually the cosine is also radical 2 over 2 because these side lengths are the same. So they're going to be the same distance and the same ratio of sides. And then so the tangent of that is actually 1, the tangent of 45 degrees. Now 60 degrees, so that would be like, say, like if this were our reference angle, the sine of 60 degrees is radical 3 over 2, the cosine is 1/2, and the tangent is radical 3. One thing to remember is sine and cosine are complementary functions. Notice 1/2 and 1/2. So the sine of 30 is the cosine of 60. The sine of 60 is the cosine of 30. So there you go. Then lastly is 90 degrees, and again, we'll get to that when we look at the unit circle later in the year. So the sine of 90 is 1, the cosine is 0, and the tangent of 90 is undefined. And we'll talk a little bit about that too. So I just wanted to show you an easy way to kind of remember these. So yeah, I'll take a look, and we'll take a look at that right now. Okay, students, so I just wanted to show you a quick trick to remember all of these trig ratios. If you have a left hand, you can do this because here, look, the left hand forms like a little radical symbol, right? And then what I did is I drew a little 2 down here on my wrist, and this is a fraction line. So this is the denominator. And then the fingers are going to represent the numerator for sine or cosine. We have 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So if I'm thinking about, say, 0, if I put down my 0 finger, which is my thumb, any fingers over here on the left represent sine. Everything on the right represents cosine. So I have 0, so radical 0, because everything on all of your fingers are under the radical. Radical 0 over 2 is just 0. So that's the sine of 0. Cosine is radical 4 over 2, which is just 2 over 2, which is just 1. 30, radical 1 over 2, which is just 1/2. That's our sine. Cosine, radical 3 over 2. Radical 3 over 2. That's cosine of 30 degrees. 45 degrees. 2 fingers. Sine, radical 2 over 2. Cosine, radical 2 over 2. 60 degrees. Sine, radical 3 over 2. Cosine, radical 1 over 2, which is just 1/2. 90, this is the last one. Sine is radical 4 over 2, which is just 2 over 2, which is just 1. And cosine is radical 0 over 2, which is just 0. Okay, then you're probably wondering about tangent. Well, tangent actually equals sine over cosine. So what I can do is I can turn my hand. So 0, and how many fingers do I have up top? 0 over 4, and everything goes under the radical here. So that would be 0 over 2, which is just 0. Okay. Radical 1 over radical 3, this is the tangent of 30. And if you look at your tables, radical 1 over radical 3, yeah, that's 1 over radical 3, which is what we wrote down, which is just radical 3 over 3 rationalized. Tangent of 45, radical 2 over radical 2, that's just 1. Tangent of 60, radical 3 over radical 1, which is just radical 3. And then the tangent of 90 is radical 4, which is 2, over 0, but I can't divide by 0, so that's undefined. So there you go. That's the little hand trick. Hopefully that helps some of you remember some of these. Otherwise, you have the little table to help you out. So let's take a look at a couple of sample problems. So the first problem we're going to look at is this one. Find the length of side x in simplest radical form with a rational denominator. So here's the diagram of the problem. And so this is an example of a delta math question. So here, this is a 45, 45, 90 triangle, a right isosceles triangle, and here is x. So the first thing I want to do is think of SOHCAHTOA, and I'm going to label all of my sides. So I just chose this as my reference angle. You could have chosen this one. They're the same, so it doesn't really matter. So here's my hypotenuse. Here's my adjacent side. Here's my opposite side. So if I'm looking for my adjacent over my hypotenuse, that's the cosine. So the cosine of 45 equals 6 over x. Let's look at that little table that we just filled out. Or radical 2 over 2, cosine of 45 degrees. That's these two fingers, my pinky and ring finger. So it's going to be radical 2 over 2. So what I can do is say the cosine of 45 degrees equals radical 2 over 2. Now I can set these two things equal to each other. So radical 2 over 2 equals 6 over x. Well, now that I have two fractions equal to each other, what do I need to do? I need to do some cross multiplication here. So I get x radical 2 equals 6 times 2, which is that's just 12. So I need to actually get x by itself. So I'm going to divide both sides by radical 2. But I need to rationalize the denominator. And that means that there's an irrational number in my denominator. So delta math wants you to put them in rational denominators. So what do? I actually have to multiply this by radical 2 over 2, which is just 1. So then if I multiply across, what do I get? 12 radical 2. And what's radical 2 times radical 2? So remember, when we have two radicals multiplying together, we can multiply them under the radical. So that's just 12 radical 2 over radical 4. But what's radical 4? 2. That's the square root of 4. So 12 radical 2 over 2, 12 divided by 2 is 6. So that's your answer. It's 6 radical 2. So some of them can be a little tricky. Some of them are a little easier. You'll see as we go through some delta math examples. So that's the first one. The next one I wanted to look at, find the length of side x in simplest radical form with a rational denominator. So here's the new problem. This is a 30, 60, 90 triangle. And they gave us the length of the hypotenuse, and we're looking for this side. So let's remember SOHCAHTOA again. And so if I chose this as my reference angle, and again, it matters where your point of reference is, where your reference angle is, because here's my opposite side, here's my adjacent side. That's always going to be my hypotenuse. If I chose this as my reference angle, then this would be my opposite side, and this would be my adjacent side. So since I chose this, I'm going to use sine because I'm looking for my opposite side, and I know my hypotenuse. If I chose this angle, I would have to use cosine. So it's the sine of 60 equals x over 2. But I know the sine of 60 equals radical 3 over 2. So it's just a matter of setting those two things equal to each other. So x over 2 equals radical 3 over 2. Well, I could cross multiply, but I could just multiply both sides by 2. And actually, if you notice this, that both the denominators are the same, then you know whatever in the numerators must be equal to each other. And here's why. So if I multiply both sides by 2, well, those all simplify to 1. So I'm just left with x equals radical 3. So that's a little shortcut. If you notice that, the denominators are the same, then the numerators have to be equal. One more. Find the length of side x in simplest radical form with a rational denominator. So here it is. It's another 30, 60, 90 triangle. That's bright yellow. SOHCAHTOA. All right, so I'm going to choose this as my reference angle. Then I know, okay, here's my hypotenuse. This is my opposite side. This is my adjacent side. I don't know anything about the hypotenuse. I'm not looking for it. So it's actually tangent that I'm dealing with now. So the tangent of 60 degrees equals radical 6 over x. Well, I also know the tangent of 60 degrees equals radical 3. So what I can say is radical 6 over x equals radical 3. Perfect. So all I need to do is go ahead and multiply both sides by x. And what am I left with? All right, well, that actually gets me to radical 6 equals x radical 3. But then I have to divide both sides by radical 3. So what's radical 6 over radical 3? Well, I can put that all under one giant radical. And so it's just 6 over 3 under the radical, which is just radical 2. So there's my solution for that one. I wanted to show you this one a little bit in a different way, like if we chose the other reference angle. So let's set that up. So here we go. Let's just erase all that. Let's say we said this is our reference angle. Now this is our opposite side and this is our adjacent side. So everything just kind of flips around. So the tangent of 30 is x over radical 6. Well, I know the tangent of 30 equals 1 over radical 3. So I can set those equal to each other. X over radical 6 equals 1 over radical 3. Multiply both sides by radical 6. And then you're back in the same solution. So I just wanted to show you how they work both ways. So I hope this helps. Please let me know if you have any questions. And thank you all for watching.